All right, so we just finished up this first example, so let's continue on with the notes. If we subtract k from f of x, then we shift the graph down. So this is the next thing that you're going to want to highlight because it's also a vertical shift. But now we are subtracting k, so that means we will go down k units. Before we get into the next example, the other thing I want to go through with you that you're going to see appear with all of our transformations is a rule. So a rule can be written for all transformations. What the rule does is it's telling us how are we getting from the parent table to now the new table applying the transformation. And so that's what this first set of ordered pairs, it says x comma y. It's saying your x and y coordinates from the parent, what is happening to them to then transform into the new. And this is where we would write in those transformations. So we will be using this setup of writing a rule for these transformations for all of our example problems here on out. So it says use a table to identify points and then sketch the graphs of f of x equals x squared, g of x equals f of x, the original function, plus 2, and then h of x equals f of x, the original function, minus 5. So this mathing notation here, I know can be kind of confusing because it has a lot of f of x's, g of x's, and a lot of things going on. So to make it a little bit easier for us to understand, I have them rewritten in these tables with the x squared filled in instead of the f of x like it says in the instructions above. So if that's a little bit confusing for you, just know that in these tables, these three tables here are the three graphs we'll be creating on the grid. Okay. First things first is we have our parent table. This is our starting point. This is our original function, f of x equals x squared. I'm going to use my parent tables like I've done on the past problems with the quadratic functions, and then I'm going to graph it. So I recommend you do the same. I do tend to color code these because as we get multiple graphs on a grid, it can be helpful to have some way of distinguishing between them. And so what I'm doing, and I know you can't see it on the screen right now, but I am graphing these points. So negative 2 squared is 4, negative 1 squared is 1, 0 squared is 0, and so on and so forth. And I have these graphed on the grid. So this is our parent function. We're now going to take this parabola and apply these two transformations to it individually. So let's start with the first one. X squared plus 2. And when we're talking about transformations, I really like to highlight, well, look at how this is written and how is it different from the parent? What is new? What has changed? Well, from x squared to now x squared plus 2, the thing that's new is plus 2. And that plus 2 is happening outside of this original parent function of x squared. It's on the end. So what that is telling us is that this is a vertical shift up 2. So this plus 2 means I'm going to take my original parent function and I'm going to move all my points up 2 units. Now again, this is vertical, which means it's affecting my y values. So let's get some practice on writing the rule. So the rule, x comma y, the original parent coordinates are going to change by adding 2 to your y values. Because this is vertical, which means the x value, which is the horizontal axis, is not being affected. It's the y values that are being affected by this plus 2. That's what's going to move everything up 2 units. So when I'm looking at this original parent table and how I can create this new table for x squared plus 2, I can apply this rule because all of the x's are going to stay the same from the parent to the new. X is staying x, it's not changing. So I'm going to fill those in, and they're going to match because in this rule, x stays x. It doesn't change. But the original y's from this parent table, it says the transformation is to add 2 to each of them. So 4 plus 2 gives me 6. 1 plus 2 gives me 3. 0 plus 2 is 2. 1 plus 2 is 3, and 4 plus 2 is 6. And now I'm going to graph these points. So you can see these original points I have here. Another way that I could have graphed it, other than applying the rule, is I could have looked at these points I originally had and just moved them up 2 units versus applying the rule. So know that there's going to be multiple ways to approach these problems, and that's okay. If you figure out a method that works for you and still gets the same end result here, but that's okay. All right, let's do the next one. H of x equals x squared minus 5. The thing that is different here from this original x squared to now x squared minus 5 is the minus 5. And that means we are going to be moving down 5 units. Writing a rule for this, x comma y, so this is your parent xy coordinates are transforming into, well, this is a vertical transformation, so my x is going to stay x, meaning all of these x values from the original parent table are just going to carry over. So I'll fill that in now. And all my y values are going to see the effect of this down 5 or minus 5. So the original 4 minus 5 is negative 1. 1 minus 5 is negative 4. 0 minus 5 is negative 5. And then negative 4 and negative 1. And graphing these. And visually, again, you can see that we could have also taken these original blue points and just moved them all down 5 and connected them to get the purple graph here. Next is part B, which is another example that's very similar to the one we just did above, but it's with cubic. So take a moment to pause the video and then move on to the next video to then see the answers for that.